Hello guys, welcome back to our video lecture series. In last video lecture, we have learned in this chapter index properties about some index property of soil, a practical methodology like specific gravity to find out moisture content throughout oven dry method, sand replacement method, and rapid motion method. Then we learn sieve analysis method to find out the percentage of coarse soil, then hydrometer to find out fine grain soil. Also, we have covered sand replacement method, core cutter method. So basically, all the practical to find out the density, void ratio, specific gravity, moisture content, that type of practicals we cover in last lecture. Today in this lecture we are going to understand about the consistency limit and some miscellaneous property of soil. So let's start without wasting any time. And yes, also we covered that attribute limits too, like liquid limit, plastic limit, sinkage limit, and also learn how to find that particular limits. On the behalf of that, this consistency indices are also a main and basic property of soil. So let's take a look. First one is flow index. Flow index is the slope of the flow curve obtained between the number of flows and water content in the Casagran test to determine of liquid limit. Flow index indicates the loss of shear strength of soil upon the increase of water. Greater the slope angle, lesser is the shear strength of soil. Flatter slope curve indicates more shear strength into the soil. A flow index is denoted by IF. The value of flow index determined from the equation W1 minus W2 upon log 10 N2 upon N1. Here we have to understand that into the second point, I told that flow index indicates the loss of shear strength of soil upon the increase of water. So definitely we know that the shear strength of the soil will be increased if the soil is in solid form. While we are increasing the water content into the soil sample, it will reach to its plastic limit. Further increment in water will reach it to the liquid limit. And we know that the increment of water exceed to the liquid limit will result into the loss of shear strength. Then after we can get very less amount of shear strength of soil. Our next topic is consistency indices. The consistency limit is denoted by IC. The consistency limit is the ratio of the difference between the liquid limit and natural water content of soil to its plasticity index. Here, the plasticity index is nothing but a subtraction of the plastic limit from the liquid limit. The equation of plastic limit is WL minus WP, where WL is liquid limit and WP is plastic limit. Plasticity index denoted by IP. This is very important to attribute the soil property. Here into the table there are some conditions. On basis of that conditions, we have the value of consistency limit. Throughout that consistency limit, we can understand the nature of soil. So first one is, if liquid limit is equal to the natural water content, then the consistency index will become 0. At that time, the soil is at liquid limit. Second one, if liquid limit is less than of the natural water content, then consistency indices will become negative value. A nature of soil is still in liquid state. And last one, if liquid limit is greater than the natural water content, then consistency index will become positive value. At that time, the nature of soil will behave like solid or semi-solid state. Here, a consistency limit or consistency index will be derived from the equation WL minus WN divided by IP, where WL is liquid limit, WN is natural water content, and IP is the plasticity index. Now, liquidity index. Liquidity index is denoted by IL. The liquidity index is the ratio of the difference between the natural water content of soil and its plastic limit to its plasticity index. The value of liquidity index will be lies between 0 to 1. A liquidity index is solved throughout the equation Wn minus Wp divided by Ip. Here Wn is natural water content, Wp is plastic limit, Ip is plasticity index. Also here liquidity index is 1 minus Ic. Ic is consistency index. Next, toughness index. Toughness index is derived by IT. It is the ratio of plasticity index to the flow index. The toughness index will gives us an idea of a shear strength of soil at plastic limit. Toughness index is solved throughout the equation IP divided by IF. As we know, IP is plasticity index and IF is flow index. Density index. Density index is denoted by ID. A density index is the ratio of difference between the void ratio of a cohesion-less soil in the loosest state and a void ratio in its natural state to the difference between its void ratio in the loosest and densest state. A density index will be derived from the equation E max minus E natural divided by E max minus E minimum into 100. Here E denotes for the void ratio. E max denotes maximum void ratio. E natural denotes natural void ratio. E minimum denotes minimum void ratio. A density index is also known as relative density. Let's move to the value of the density index. Here into the table there are different soil conditions for the different value of density index. If the density index value less than 15, then the soil is in very loose state. If density index lies between 15 to 35, then the soil has in loose state. If the density index lies between 35 to 65, a soil is in medium dense state. If the density index lies between 65 to 85, then the soil is in dense state. And last one, if the density index is greater than 85, then the soil will be in very dense state. So there are the consistency indices. Now take a look for the miscellaneous properties of soil. First one is Sinkage Ratio. Sinkage ratio is denoted by SR. The Sinkage ratio is the ratio of a given volume change in a soil expressed as a percentage of the dry volume to the corresponding change in water content above the shrinkage limit. A shrinkage ratio will be derived from the equation of V1 minus V2 upon Vd whole in denominator of W1 minus W2 into 100. Here V1 is denoted for volume of soil at water content W1. V2 stands for volume of soil at water content W2, and Vd denotes for volume of dry soil mass. At shrinkage limit, volume of soil at water content W2 is equal to the volume of dry soil mass, so that W2 is equal to Ws. Here, shrinkage ratio we can write down as initial volume minus dry volume divided by dry volume whole in denominator Wi minus Ws into 100. If we rearrange this equation into the format, then we know the weight by volume is considered as a density. So this equation will become shrinkage ratio equal to gamma d over gamma W into 100, the density of dry soil upon density of water into the 100. Now take a look for the sensitivity. A sensitivity is denoted by St. Sensitivity is defined as the ratio of unconfined compressive strength of an undisturbed soil sample to the unconfined compressive strength of the same soil after remolding at unaltered water content. So the equation of sensitivity will become Qu undisturbed divided by Qu remolded. Here Qu is nothing but the unconfined compressive strength. As we understand into the definition, Here, into the numerator, Qu undisturbed will indicate a natural soil sample's unconfined compressive strength, and from the denominator, Qu remolded is taken as after the oven dry of soil and make a mold to achieve optimum moisture content and maximum dry density. Then after we conduct a test of UCS, and the value taken from this sample will be derived here as Qu remolded. Into the table there are some classification of soil based on the density index. The density index lies between 1 to 4, then the soil is classified as normal. If the density index lies between 4 to 8, then the soil classified as a sensitive. If the density index lies between 8 to 15, then the soil is classified as extra sensitive. And if the density index is greater than 15, then the soil is classified as quick. So what happens if the soil has quick sensitivity? Here I can see you one video. And currently at 4th June, about 4th June, there will be a disaster happen in the northway due to this quick sensitivity of clay. Here you can see that the whole land will be slide into the water with the very quick sensitivity. Into the quick sensitivity condition, if soil has little disturbance, then it will be lose its shear strength. Now let's move to the next topic, activity. Activity, it is the ratio of plasticity index of the soil to the percentage of final fraction available into it. A clayey soil exhibit more activity value because it has more amount of finer particles. The activity will be denoted from the equation IP divided by percentage by weight of finer than 2 micron. Here obviously the percentage finer than 2 micron will consider as a clay. To determine the percentage by weight finer less than 2 micron, we have to perform a hydrometer test. Here we can see into the table. From the activity value, we can classify the soil as that. If the value of activity is less than 0.75, then the soil is classified as inactive. If the activity value lies between 0.75 to 1.25, then the soil is classified as normal. And the activity value is greater than 1.25, then the soil is classified as active soil. So what happened in this active, normal and inactive soil? In active soil, when we add some moisture, then it will be react as much as quickly. In active soil, it will less amount of reaction, and into the normal, it will behave normally. So guys, today we complete our lecture here. Hope you can understand all the index properties. Today we learn consistency indices and some miscellaneous properties. Thank you for listening. See you into the next lecture.